This example is for MTB 1370 for Chapter 10, which deals with dosage calculations using the D divided by H times Q method versus the method that is explained in Chapter 14, which is the proportions method. Now, either method you choose, the Chapter 10 or Chapter 14 method of calculating dosage calculations, we're going to use a three-step approach when we're solving these problems. The first step is that we have to convert to the same unit. Thus, the order from the physician and the supply that we have on hand has to be in the same unit of measurement, whether that is in milligrams, grams, or some other unit of measure. Generally, we convert to the smaller unit of measure so we have less decimals in the problem. The second step, when calculating dosage, we are going to estimate what is a reasonable answer prior to calculating the result, either using the formula from Chapter 10 or proportions from Chapter 14. And the third and final step is to calculate the dosage. In Chapter 10, we'll use the formula method D divided by H times Q is equal to the desired dosage. Now, in Chapter 10, we said we're going to use the formula method, and the formula is stated on the screen, and it's D divided by H times Q is equal to the amount that is desired. Now, the D in the numerator stands for what is desired from the physician. That might be a certain number of milligrams or a certain number of grams of the medication. So D is desired, and it is what is ordered. So I'll write order up there. The H in the denominator is what we have on hand, how it's packaged, so that you could think of as the supply. Again, that would usually be in milligrams or grams or micrograms. And we times that fraction by the quantity. Now, when we're dealing with tablets or capsules, the quantity Q is usually one tablet or one capsule. If we're dealing with medication that is given in liquid form, then Q could be anything. Generally, it's a certain number of milliliters, 5 milliliters, 1 milliliter. And if you divide D divided by H and then times it by Q, you get the amount that needs to be given to the patient. We have two examples that we're going to look at. And again, the directions say, in each of the following problems, use the formula method. So we want to use the formula method, not the proportion method, which is explained in another video, to find the amount of medication needed. It says you are asked to administer 200 milligrams of niacin by mouth, PO means by mouth, daily. It is supplied in 100 milligram tablets. How many tablets do you need to administer? All right, so we're going to write the formula. Again, the formula would be D over H times Q is equal to the amount that we have to give the patient. Now, in this problem, D stands for desired, which is what is ordered. Now, what is ordered is 200 milligrams, and it's supplied, or what we have, is 100 milligrams per every one tablet. So you notice both the order and the supply is in milligrams. Thus, step one of converting to the same unit, we do not need to convert to the same unit because they're already both in milligrams. Now, before we plug and chug into the formula, if we're asked to administer 200 milligrams of the medication, and we know each tablet has 100 milligrams of that drug, then I would estimate that we would need to administer 2 tablets, because 2 times 100 is 200 milligrams. So my estimate in step 2 would be 2 tablets. Step 3 is to calculate using the formula. So what is ordered, or what is desired, is 200 milligrams. We divide that what we have on hand, or how it's supplied. It's supplied in 100 milligrams per every 1 tablet. So the quantity will be 1 tablet. Now the quantity is not our answer, but that's the quantity of tablets we need to get 100 milligrams, which is our supply. Now when we simplify this, the unit of measure should divide out, since we converted to the same unit if we needed to, and our answer will be in the number of tablets. So 200 divided by 100 is 2, and 2 times 1 tab is equal to 2 tablets, which is what we estimated in the previous step. And hopefully that makes sense, because if you have 2 tablets and each tablet is 100 milligrams, well, 2 times 100 milligrams would be 200 milligrams, which is the desired dosage. So example 1, the answer would be 2 tablets. Example 2, again, we're still going to use the formula method from chapter 10, but in this case our medication is given in liquid form instead of tablet form. And in problem 2, it says you're asked to administer 62.5 milligrams of Ciclor. It is packaged that there's 125 milligrams in every 5 milliliters of solution. The question says, how many milliliters do we need to administer? Well, again, in these beginning problems, we should always do all 3 steps. And the first step says convert to the same unit. But in both these examples, they're already in the same unit. So the desired is in milligrams, and how it's supplied is in milligrams. Now, if they were not, then we would have to use what we know about our metric prefixes and convert them both to milligrams or both to micrograms, whatever usually is the smaller of the 2 unit of measures. So we're asked to administer 62.5 milligrams, but we know it's packaged that there's 125 milligrams in every 5 milliliters. So we're not even going to need 5 milliliters, because that would give us 125 milligrams, which is too many milligrams. So our answer should be less than 5 milliliters. And if you looked at the ratio between 62.5 and 125, you would notice that 62.5 is exactly half of 125. Thus, we should administer half of the 5 milliliters of solution. So in step 2, a reasonable estimate would be 2.5 milliliters. Now in step 3, let's calculate and see if our calculation verifies our estimation. So in this problem, what is ordered, or what is desired for the patient to have, is 62.5 milligrams. So that's desired, 62.5 milligrams. And we divide that by what we have on hand, or the supply, which is 125 milligrams. And you see it's very important that they're both in milligrams, so the mg's will divide out. And we times that by the quantity that we need to get that 125 milligrams. Well, to get 125 milligrams, it said the quantity was 5 mLs. And recall, 5 mLs That's the same as 1 teaspoon in the household system. That might not be important in this problem, but it might be important in a problem down the road, that 5 milliliters is just 1 teaspoon. Now when we simplify this, as we said, the milligram units divide out, and we get 62.5 divided by 125. If you divide that on your calculator, you get 0.5 or 5/10 or a half. And then we times that by 5 mLs, 5 milliliters, which is a teaspoon. And if we go 0.5 times 5, we would get 2.5 milliliters, which is half a teaspoon. So we would need to give the patient 2.5 milliliters of that solution, and then the patient would have 62.5 milligrams of the medication. And recall, when we write milliliters, the L must be capitalized, the M in front of it has to be lowercase, and since that is in the metric system, we would like that written in decimals, 2.5 or 2 5/10, written as a decimal instead of as a fraction. So we wouldn't want to write that as a mixed number, 2.5 written that way, since we're dealing with a metric system. In the metric system, we prefer decimal notation rather than fraction notation. So these are two beginning examples from Chapter 10, Dosage Calculations, using the formula method, D divided by H times Q.